All right, hey Ellie and whoever else 8th period is watching this. This is Chapter 5 review. We are on day 2, which means test is tomorrow. And we are, I think yesterday, maybe the 6th period class got through number 8. 8th period, we didn't get quite that far. I think we stopped after this section. So we're going to do number 9 together just to get everybody all back on track. So number 9, starting with this, is a linear function, right? And we want to graph him. And we start at -3, right? And then go up 2 over 1, and he looks like this. Yeah, we did stop at this one yesterday, I think. Okay, so the original guy looks like that, something like that, right? And then we have to find the inverse, okay? F of x is the same thing as y, and then we switch our x and y, right? X equals 2y minus 3. Okay, then what? What? Add the 3 over, right? So this guy is x plus 3 equals 2y. Yep, then what? Divide by 2, divide everything by 2. X over 2. I don't like to write it like that usually. I like to put it as 1/2 x, right? Plus 3 over 2 equals y, or if you like to rename him, he's f inverse of x equals 1 over 2x plus 3 over 2, okay? Where do we start there? 3 over 2? 3 over 2 as a decimal is 1 and 1/2, so right here. And then from there we go up 1 over 2, up 1 over 2, or down 1 over 2, down 1 over 2. So he's kind of like in that in-between point right there. And then you connect all those dots. Okay, something of that nature. I'm going to put that dotted line in here. This line, do you remember what his equation was again? Y equals x. Y equals x. Does it look like he's flipped over top of that? Yeah, he should. Okay? All right, do you want to go ahead and do number 10 and go through it together here in a second? Or do you want to just skip to the back side? What do you want to do? So you do it, and then I'll do mine, and then you check with me. Okay? All right, so I'll give you a second to do that. And if you're watching this video and you already have this done, you can skip through or skip ahead. I'll give you guys a couple minutes to start, and then I'll go. Oh, that wasn't very nice of me. I know, it's kind of hard. Are you guys ready? We'll talk through this one. Number 10, so you get to a point when you're finding the inverse where you have 1/4 y, and rather than dividing by 1/4, you guys know that you can take it times 4, right? But if you take times 4, you have to take everything over here times 4. So 4x plus 8 is what it should be, right? Okay, if we go to graph that, it would be starting like up here at 8, okay? And then the slope is 4, so it's up 4 over 1. Or we could go down 4 to the left 1, right? Now, if we go down 4 to the left one, we actually are back on the graph, right? Down 4 to the left one is this dot right here. If I go down 4 to the left one, it's over at -2, 0. Down 4, left 1. Now we are back on the graph again. Does that make sense? Yeah? Okay, so I'm going to connect those dots. Good one here. Something like that. Okay? And if we do our dotted line, that y equals x line, it kind of looks weird because the x and y axis are not positioned in the middle. But that's what he looks like. Yeah? He does look like he's reflected across. Happy with that? Okay? All right, let's go to the back side. side. 11, 12, 13. This is typically something that people forget how to do. So determine whether the functions are inverses of each other, right? Yes or no, okay? So to do this, I want you to plug them into one another. So we're gonna first do f composed of g, and then we're gonna do g composed of f. We're gonna stick them inside of each other, okay? All right, we're gonna stick them inside of each other. If we do f composed of g, that means g goes into the f function. This is going into the f function, all right? So instead of 3x minus 1, I put that other stuff inside of it. So 1/3 x plus 1/3. Okay? Now, what do we want it to come out to be? No, not quite. No. X, right? When we graph inverses, they're reflected across the line y equals x. So when we stuff them into each other, they have to reduce to be x, and that's kind of why that is, okay? So everything will cancel out except the x, hopefully, okay? If it doesn't, they're not inverses. 3 times 1/3 x, what is that? Just 1x, right? Okay, 3 times 1/3 is just a positive 1 minus 1. X, that's what we want, okay? Now let's stuff it in the other way, okay? So I'm going to start with the 1/3 x plus 1/3, and I'm going to stuff the other stuff in there. 3x minus 1, that's what I'm going to do, okay? Am I going too fast? Are we doing okay? If I distribute the 1/3 times 3x, that's just x, and 1/3 times 1 is negative 1/3 plus 1/3. What's that come out to be? X, right? Those 1/3s cancel off. So what does that mean? Yes, they are inverses. Yes, they are. Okay, good. All right, 12, 13. Do you want time to do those? You want to do another one of them together? I don't care. Otherwise, I'll just let you go and then I'll join. How about that? Okay, just like we've been doing. Okay. Some of these might be no's. I have no idea. A little less heat? Yes. It just kicked off.
Oh, okay.
But I can turn it. I can make it. Well, I guess if I do colder. Yeah. Let me do colder. And then
The kids were complaining. I know you're bringing stuff and cooled down so much faster than mine is.
I'll turn it down and then it will keep on for a while.
Okay.
I just told you to kick it up and then they. Oh well, I'll just teeth chatter over here, I guess, or something. I don't know.
Just walk outside, it's not that hard.
Ah! It just kicked on again.
Probably during cold air, you turn it down.
Yeah, but it's either on heat or on cool. I don't think it switches from. Is it? I don't know. I don't know what it's doing. Okay. Okay, did you get through those last two? 12 and 13? 12 is a yes, right? 13. I did f composed of g, and I have 1/20 minus 10, and those are not going to go away, and that's not going to become x, right? So, don't waste your time doing the second one, because it already fails, right? That one's going to be a no matter what. All right? If one of them fails, you don't even have to do the second one, right? Happy with that? Okay? Are we going too fast? You ready to move on to the next section? Yeah? Okay, here we go. These ones identify the domain and range. All right, 14 is a square root function, right? A square root, okay? If we remember 14, 15, 16, those are all square roots, right? If we remember, a square root function just starts here in the middle and goes this direction, right? Just there, okay? So we have to decide what's the plus 2 doing to it? Left 2. It's going to the left 2. So now I have it over here to the left 2, and it's doing one of those. Now we have to identify domain and range. Do you remember a while back doing domain and range and it was all reals and all reals? Is this all reals, all reals? No, how's come? Cubic root is all reals, right? So square root is not, okay? The square root, though, has to do with where this point is. This point is at negative 2 comma 0, okay? That's going to show up in our domain and range. So for domain goes left and right. Okay, he's not going to go left forever, but he is going to go to the right forever. X's have to be what? Greater than or equal to negative 2, because that's the x coordinate, right? Okay, the range, those are going to be just y's that are greater than or equal to 0, exactly. Okay, all right, do you want to try to do these other ones by yourself?
Yeah.
I do like a little rough sketch, and then I do my domain and range, okay? All right, I'll give you a head start, and then you can check with me. You don't have to be particular, but the important thing is that it actually is not going to change the string at all, right? It's just gonna make it taller, but it's not changing it. So that's the important part. If you just guesstimate, I'm fine with that. Okay. All right, good. 15. He's visibly just a little bit taller, and he shifted to the right. So 4 and 0 are my domain and range. Those guys. 16, since he's flipped down, that's the only time you flip this symbol right here. Y is less than 0 now because he's going downward, right? X is still going to the right, so he's still greater than, but the Y's are flipped down. Did you get that? Happy with that? Okay, let's go to the next section. Do you want to, I guess I've just been doing the first one together. Would you like to do a different one? 17, 18, 19, would you rather do a different one? Which one? You just want to do 17? Sure? Okay. All right, so 17, that 2 is on the inside. What's that 2 do? What? It's a horizontal, actually, it's a horizontal compression by 1/2. Okay? A horizontal compression, if you make something go horizontally compressed, you make it skinnier, it's going to be taller. So it's kind of the same as a vertical stretch. Does that make sense? Horizontal compression is going to look like a vertical stretch. So it's kind of going to be taller, but he's going to be skinnier also. Does that make sense? Okay. So those two kind of go hand in hand a little bit. But he's still going to look like a square root function. He's still going to start here at 0, 0 because we're not moving him left, right, up, down. He's just going to be taller. Okay. Because he's skinnier, it's just going to make him taller, right? Domain and range. Stretches and compressions don't change your domain and range. The only thing that changes it is if you move him left, right, up, down. Okay? So your domain, the x's are still greater than or equal to 0. Your range, the y's are still greater than or equal to 0, right? Because this dot right here is still 0, 0. Okay, does that make sense? If you vertically stretch a compression, it's not going to move your domain and range. Okay, good? Okay. 18, 19, get a head start, and then I will go. Okay, there's a lot of zeros going on because we're not moving him left, right, up, down at all. It's just stretching him out, right? Either stretching or flipping or whatever. Okay, not moving left, right, up, down. Happy with that? Move on to the next section. Okay, next section. Find the inverse. Ugh. I didn't give you any cubic roots to graph, did I? What? Silly. Find the inverse of the function. All right, 3x to the, I guess these are cubic roots. These are going to be the ones we're going to have to graph. All right, 3x to the third power. Let's just graph that original one. What does he look like? What's x cubed look like to start with? Yep, one of these, okay? The 3 is going to make him taller and skinnier, so he's just going to be really flat here. Like that, something of that nature, right? Okay? All right, now we want to find the inverse. So the 4 steps, y goes in that spot, and then you switch your x and y. So x equals 3, y to the third. All right, now we're solving for y. What are you going to move? Divide by 3. Divide by 3, divide by 3, okay? I like to write, instead of x over 3, as 1/3 x, right? Equals y to the third. And then I take the cubic root. Cubic root, cubic root. Okay, so we've got f inverse of x is the cubic root of 1/3 x. Okay, we know what a cubic root looks like, right? He does like this and like this. What's a 1/3 gonna do? It's a horizontal stretch, actually, because it's by 3. So it's a horizontal stretch by 3, which is kind of like a vertical compression, right? So he's going to be shorter to the line, right? Kind of like this one was. He's going to be closer to the line, right? So he's going to go like this ways. Something of that nature, right? Now does he look like he's flipped? Yeah, I think so. I mean, my drawing's not great, but whatever. Happy with that? Okay. All right, you try the next ones. See how that works? I think these next two. 22 is going to be very similar to that. 21 is going to be a little easier. Oop. How's that? Did you get the same thing I got? Yeah? Graphs look similar-ish. Always, after you get done graphing the inverse, always put that dotted line in there and like tilt your head to the side to see, like, does it look like it's the same on both sides? And if it doesn't, then you didn't do something right, or you didn't graph it right. Okay? Now I know mine's not perfect, but it should at least look somewhat symmetric. Okay? Happy with that? We're going too fast? No? Okay, next section. Last section. What the heck? How about we do one of the top row and one of the bottom row? Pick one. Which one you want? 23, 24, 25. 24? Sure. Okay, so we're trying to solve this thing. We're trying to solve for x and figure out what x is. What do you do first? Subtract the 12. I want to get this guy by itself, right? So I'm going to subtract the 12 over. And 4 minus 12 is like negative 8. This was the lesson I was going for. Okay, now what? Square, we got to square both sides, because when you square that square root, he will be gone, right? Square and square. So when I square this stuff on the left, it's just 2x minus 1 will like fall out of that square root bracket, right? What's going to be on the right side? Is it positive 64 or negative 64? Positive. When you square it, it's always going to be positive, right? Okay, so don't type it in your calculator with the negative, because your calculator will say it's negative, so it's not going to be negative. Okay, then we've got to add the 1 over, right? So 2x will be equal to like 65, and then divide by 2. What's 65 divided by 2? Can you do that in your head? 6 divided by 2 is 3. 5 divided by 2 is 2.5. So 32.5, yeah? Good? You can leave it as 65 over 2. Yes, that would be fine as well. I will take that. I'm okay with that. Good question. Okay, do you want time to do 23 and 25? Okay. You guys are like especially quiet today. Ellie must be the loud one, huh? Oh shoot, she's probably listening to this video. Ellie, you're the loud one. Sorry. This one's kind of tricky. When you do 23, don't forget the 5 is not negative. It's the x that's negative, right? So you still have to subtract the 5 to get it to the other side. You're not adding 5. Okay. Ah, this is another one. That's exactly like that. All right, do you get the same thing I got? Good? All right, negative 95 and 12. Yeah, when you're doing that, make sure the x is what's negative, not the 12, right? So you have to subtract the 12 over and divide by a negative 1. That one's weird. Okay. All right, 26, 27, 28. What do you want? 27? Sure. Okay, what first?
Minus 6.
-6. Yep, exactly. -6 minus 6. 3 square root of 2x minus 1 is less than, is that 9? 9. Now what? Divide by 3, yep. Because we still have to get that square root by itself, right? He's not by himself yet. Square root of 2x minus 1 is less than 3. 9 divided by 3 is 3. Then what? Now we have to square. So it turns back into 9. Well, that's convenient. 2x minus 1 is less than 9. Then add the 1, so 10. 2x is less than 10, and then divide by 2. X is less than 5. X is less than 5. Yep. Good. Happy with that? Beautiful. Okay. All right. You do 26, 28, and then we'll be done. Holy cow. This back half went fast. I guess the front half probably did too, but we had shortened periods yesterday, right? That's probably what happened. Oh, when do you flip the sign? Multiply or divide by a negative. Excuse me. I didn't do that to you though, did I? All right, how's that? Did we get x greater than 4? Yeah? Perfect? Okay, anything else on this sheet that you have questions on? What part's the hardest part?
I think 5.5.
5 is the hardest part? That one? Where you're doing the inverses and stuff too? Yeah? Do you want any more of those? No, you're like, I'm done for the day, right? We got 15 minutes left. We can get whiteboards out if you want. Or are you A-okay? You're like, I'm ready for this test, right? You ready for tomorrow? Tomorrow you'll have a little bit shortened periods. Period 6 will be, I don't know what it is, 30 minutes long? 35 minutes long? Something like that. Can you do a test in 35 minutes?
How many questions are on
15, I think. So, yeah. Okay. Anything else that you want to go over? What?
Not sure about 5.5.
Not sure about 5.5? You want me to come sit over there with you? Okay, I'll come sit with you. Okay, anybody else? All right, I'm going to stop the video. Everybody say bye, Ellie, and whoever's watching this 8th period. They don't care. They don't like you. Okay, goodbye.